Hello and welcome to this Gates webinar about belt-in-oil technology. On the agenda for belt-in-oil drive systems, we have some information about the evolution of the internal combustion engine or the ICE engine, OEM manufacturers that are using this technology, belt-in-oil technology, what is it? Gates' new belt-in-oil construction, a new belt construction, tensioner-in-oil working principle, also known as TiO tensioner-in-oil, Ford EcoBoost engines, some extra information for those, PSA-EB type engines, some extra information on those, special tools required for belt-in-oil installation, and some information about Gates websites. Engines are more complex than ever before due to the evolution of the internal combustion engine. During the evolution of the internal combustion engine, we have seen various technology trends as engine designers and car manufacturers continually push to meet strict CO2 emissions targets. One of the technologies being used to overcome emission reduction challenges is belt-in-oil drive systems. These can also be referred to as hot oil belt systems or HOB or wet timing belt systems. Now, these systems are generally 30% more efficient compared to a chain-driven system. Some advantages of belt-in-oil systems are the packaging or the width and weight equals smaller, lighter, more fuel-efficient engines, and the belt friction efficiency is improved due to operating within an oil environment compared to a dry belt system. NVH or noise, vibration and harshness improvements due to the internal location providing insulation because the belt's now operating internally and it's covered, and the wider use of belt-in-oil by car manufacturers means there is also a growing demand for an aftermarket solution. Gates' product portfolio now includes a competitive offering of belt-in-oil belts and kits for the aftermarket. Evolution of the SBDS drive system. It started with very basic designs for the SBDS systems, and due to belt flexibility it enabled more complex designs for the belt routing of the SBDS system. We saw the introduction of twin camshaft pulleys for the SBDS system as well, and also V-type engines and flat engine designs require longer belts due to further complex belt routing drive system layouts. Now we need to be aware obviously that material science has evolved since the basic SBDS systems were designed, and the evolution of the SBDS system over the last decade has led to the introduction of belt-in-oil drive systems, as we've mentioned previously, also referred to as hot oil belt systems or wet timing belt systems. Gates designs, manufactures and supplies all the OE major vehicle manufacturers globally. These are some of the OE major vehicle manufacturers that are using belt-in-oil technology within their drive systems: Ford, the VAG Group, the PSA Group, Toyota, Vauxhall, Hyundai and Kia Motors. Gates' new belt design technology for belt-in-oil drive systems. Gates' new belt-in-oil range is now available for Ford 1 litre 3-cylinder EcoBoost engines, and there are two belt widths available, 16mm and 18mm widths. The 16mm width is T359 HOB, the 18mm width is T354 HOB. Both have 116 teeth, both have 9.525 pitch, and both belts are 1,105mm long. There's one tensioner for the system, which is T43266, and for PSA applications the 1 litre and 1.2 litre 3-cylinder EB type engines, there is one belt which is 16 millimeters in width, which is T360 HOB with 118 teeth and a 9.525 pitch, which is the same as the Ford. These belts for the PSA are 1,125 millimeters long. However, there are now two tensioners available, which the tensioners have internal differences and are not interchangeable. There is tensioner T43273 and tensioner T43275, and as said previous, these tensioners are not interchangeable due to internal differences. There's also one idler included within the PSA system, which is T41331. Now, some information that you may not be aware of is that both the Ford and the PSA engines are using what's known as non-round camshaft sprockets or camshaft pulleys, which is also related to as oval pulleys or eco sprockets. Now, the benefits of the oval type sprockets is reduced timing belt forces, which means the tension force of the tensioner also decreases. Reduced friction and mechanical stress in the entire timing drive system, and reduced vibrations and noise levels or NVH, and load reduction for all system components, which then means an increased system life. Increase in ambient or under bonnet temperatures. Over the years, under bonnet temperatures have increased mainly due to smaller engines with higher outputs within smaller engine compartments. When engineers are designing SBDS drive systems, engine temperature is one of the key factors for material types that can withstand these temperature fluctuations. Materials and manufacturing processes for belting oil or wet belt systems are different to dry belt systems, and Gates' new belting oil range are designed to operate within temperature ranges from approximately minus 40 degrees up to 140 degrees C, with a peak of 150 degrees C. And Gates engineers and OEM engineers agree these operational requirements. Part number identification. To allow clear identity between Gates dry system belts and wet system belts, Gates belting oil range has a part number that starts with a T, ends with the suffix HOB for hot oil belt, as an example T354 HOB. Now, there are two main categories: oil pump belts and SBDS timing system drive belts. The oil pump belts is generally a single belt located between the oil pump and the crankshaft, and the SBDS belt or the synchronous belt drive system, the timing belt, can be a single belt obviously located within the synchronous drive system, and it can also be in kit format such as KO1T or KP1T. So the KO1T is a belt and a tensioner within the kit. The KP1T kit equals a belt plus a tensioner plus a water pump if the water pump is part of the ABDS system. The Gates belting oil product portfolio now also includes super kits, which contain engine gasket kits, crankshaft and camshaft fixing bolts, crankshaft oil seals, and we will see these later on. Belting oil system anatomy. So the location of the SBDS belt is obviously to the top part of the engine, and the location of the oil pump belt is generally to the lower part of the engine. Now, we need to be aware that we can see the SBDS belts are around about 16mm to 18.1mm in width, depending on application, and oil pump belts are approximately 10 to 11mm in width. again depending on the application. So smaller width belt designs require smaller width tensioner designs, so this also leads to reducing the packaging space required within the engine compartment, and it also helps to reduce system weight, which helps the OEMs with better fuel efficiency and reduced emissions. There is misconception for the terminology belt in oil. The terminology suggests the belt is submerged completely in engine oil. However, this is not 100% correct. As we can see on screen, the SBDS belt is not submerged directly in oil. However, it does receive a heavy oil spray or mist from the rotational speed of the oil pump belt, which is below. We also need to remember the system also has a belt cover which will contain the oil spray, and therefore the belt is operating within an oil environment. Now the oil pump belt is operating directly in oil. However, approximately only half of the oil pump belt is fully submerged in oil, as we can see by the oil level within the crankcase cover or the sump. We also need to note that some systems may be installed with a chain-driven oil pump, and this will obviously be depending on the vehicle application. Correct engine oil. Internal combustion engines require oil to ensure all moving parts are lubricated to enable efficient engine operation. However, using the wrong oil can lead to incorrect lubrication and therefore reduction in engine performance and working life. Oil is generally manufactured using a base oil, refined from crude oil. A variety of additives are then added, such as anti-wear agents, friction modifiers, detergents, rust inhibitors, buffers, and antioxidants. Oil manufacturers have many formulas to ensure the correct oil specification is achieved. Oil viscosity. Engine manufacturers spend a lot of time researching, designing and testing engines, ensuring the correct SAE viscosity rating of oil is selected for lubrication and performance capabilities. Selecting a thicker viscosity oil may cause an engine to overwork and therefore be less efficient. Selecting a thinner viscosity oil may lead to premature engine wear. OE oil and filters. The correct oil with the correct SAE viscosity rating, as recommended by the OE vehicle manufacturer, should always be used for vehicle maintenance, and always install OE quality specified oil filters to ensure fit form and function is not compromised. Engines burn fuel. When engines burn fuel, harmful contaminants build up and are captured within the engine oil. Contaminants such as unburned hydrocarbons or fuel particles contained within the blow-by gases mix with the engine oil. Over a period of time, the engine oil contained within the crankcase sump will start to degrade due to the unburned hydrocarbons. Degraded oil. Degraded oil will eventually affect the belt's operation, leading to swelling and deterioration of the belt's rubber compounds and fibers, also causing separation of the bonding between the belt teeth, the backing fabric and high-strength tensile cord pack. Eventually, belt failure will occur, causing catastrophic engine failure. Damaged parts. Other internal combustion engine components may also be affected from deterioration of the belt. Belt debris enters into the lubrication system, blocking oil feed pickups, VVT solenoid valves, turbo oil supply pipes, and oil filters. These components should be checked and cleaned. However, it is recommended as best practice to replace these components. The OE recommended service intervals should be followed and ensure OE quality specified oils and oil filters are installed to aid the belt protection and therefore reducing premature system failure. Damaged parts belt. Particles shown on the belt teeth are from the deterioration of the belt's rubber compounds. The back of the belt is cracked. As discussed previously, contaminants such as unburnt hydrocarbons or unburnt fuel particles mix with the engine oil. The degraded oil will eventually affect the belt's operation, leading to swelling and deterioration of the belt's rubber compounds and fibers, causing separation of the bonding between the belt, teeth and backing fabric.
Goed, ja, dat is gefixt. Yes.
Damaged parts oil pump. Belt debris enters into the lubrication system, blocking oil feed pickups as shown in the video. VVT solenoid valves, turbo oil supply pipes and oil filters can also be affected. These components should be checked and thoroughly cleaned. However, it is recommended as best practice to replace these components. Damaged parts turbocharger. Blocked oil pump pickup and blocked turbo oil supply pipes leads to insufficient oil supply to the turbocharger, resulting in failure of the turbocharger, and the video shows the bearings have collapsed internally due to the amount of impeller shaft movement that's present. Composition of fuel. So here we can see petrol and gasoline is made up of 8 carbon atoms and 18 hydrogen atoms as shown on screen. And diesel is made up of 14 carbon atoms and 30 hydrogen atoms, again as shown on screen. We can also see the formula for petrol and gasoline, which is C8H18, so it's 8 carbon atoms in black and 18 hydrogen atoms in grey. Diesel is C14H30, which equals 14 carbon atoms, black, and 30 hydrogen atoms in grey. We can also see the symbol, which is the molecular structure for both petrol and diesel fuel types. Hydrocarbons. Hydrocarbons are organic compounds made up of hydrogen and carbon atoms. They are extracted from crude oil to produce petrol and diesel fuels. Hydrocarbons can be in forms of liquid or gas and are highly flammable. So they include methane, propane, hexane, benzene, but many others also exist. So we can see the symbol is the molecular structure for the main hydrocarbon types. Now we need to be aware, as mentioned previously, unburnt hydrocarbons or unburnt fuel particles and contaminants mix with the engine oil, which degrades the oil over a period of time. Driver awareness. The vehicle owner may experience problems such as power loss, oil pressure warning light eliminates on the dashboard, limp home mode is activated, leading to further investigations of the timing belt system and lubrication system. Diagnostic OBD or DTC codes may also be logged in the ECU. If the vehicle owner experienced the problems as listed, it is likely that OBD and DTC codes, as shown below, will be logged in the ECU, leading to further investigations of the timing belt system and lubrication system as mentioned previously. So these OBD or DTC codes may be P15A1, lubrication system oil pressure too low in mechanical mode, P15A8 oil pressure fault, coherence with atmospheric pressure, oil pressure too low in relation to atmospheric air pressure. We also need to be aware that the customer may also complain about hard brake pedal and reduced braking efficiency. Service interval recommended checks. Due to the issues highlighted earlier, it is highly recommended to keep up to date with the OE servicing and maintenance intervals. A visual inspection of the belt should be carried out during the service check intervals at approximately 12,000 miles to 16,000 miles or every 12 months. The condition of the back of the timing belt can be achieved when the engine oil filler cap is removed, and a visual belt check could potentially stop catastrophic engine damage, which we'll be discussing shortly. Recall information, UK and Europe. Before proceeding further, consider contacting the OE vehicle manufacturer. Why contact the dealer, you may ask? To confirm if there are any outstanding recall or service notifications for the vehicle, yes or no. Any further investigation and repairs may be covered by the vehicle manufacturer main dealership warranty services. Please be aware there are lots of stories and videos on the internet and social media platforms regarding vehicles with belt-in-oil systems. Only the vehicle manufacturer will be able to advise if there are any outstanding recall or service notifications for a specific vehicle. If the OEM confirms there are no outstanding recall or service notifications for the vehicle, further investigation will be required. In this case, for PSA petrol 1 and 1.2 EBO EB2 3-cylinder PureTech engines. So belt check. The condition of the back of the belt-in-oil belt can be viewed when the engine oil filler cap is removed. If the belt's okay, generally, if the back of the belt is smooth in appearance, without signs of cracking, the belt is in good condition. If cracks are visible, further investigation will be required. If the belt's not okay, then the back of the belt will have a rough textured effect with patchy sections and cracks. These are signs the back of the belt has started to deteriorate, causing separation of the belt coating. Oil contamination is the general cause, as we've discussed previously, and particles of the belt will now be circulated within the oil supply system. The engine oil will need to be drained, so the sump pan or the crankcase cover needs to be removed, and check the oil pump strainer gauze if rubber, belt debris and contamination are present. The oil pump strainer and belt should be replaced. Belt check. With the engine oil filler cap removed, the timing belt will be visible. Gates belt test gauge tool GAT5249 can be inserted through the oil filler cap opening. If the belt is okay, and if then the tool passes over the belt as shown, then the belt has not swollen. Investigate belt appearance further and component checks may be required. If the belt is not okay, if the tool does not pass over the belt as shown, then the belt has swollen excessively and will require changing as soon as possible. Investigate the belt appearance further and component checks may be required. Now we need to be aware that the Gates tool GAT5249 can only be used to check Gates belt T360HOB as well as the OE and competitor equivalent belts which are for the PSA models. Gates AutoCat lists vehicle applications that the GAT5249 can be used for. At present, there are no tools available for checking the Ford applications. Vacuum pump check. It is also recommended to remove the vacuum pump and inspect the gauze filter located on the rear of the component. If belt debris is visible, braking efficiency may be affected. The component should be checked and thoroughly cleaned. However, it is recommended as best practice to replace these components. Turbo feeds and VVTs. Variable valve timing solenoid valves, along with the turbo oil feed pipe, fixing bolt and banjo connector, should be removed and inspected for any belt contamination. If debris is present, it is recommended to replace the VVT solenoids, clean or replace the turbo oil feed pipework and connections as necessary. Seal replacement is also recommended. Belt check. As suggested previously, oil contamination may lead to the belt swelling. Gates belt test gauge tool GAT5249 should be used to check for belt swell. Swelling of the belt can cause excessive binding issues and failure within the synchronous belt drive system. Belt in oil, belt construction. Belts operating in an oil environment are manufactured differently to belts for dry synchronous belt drive systems. Gates new belt in oil construction. As highlighted earlier, over the years there has been an increase in ambient underbonnet temperatures. Materials and manufacturing processes for belt in oil wet belt systems are different to dry belt systems. Gates new belt in oil are designed to operate within temperature ranges from minus 140 degrees C to plus 140 degrees C with a peak of plus 150 degrees C. Gates engineers and OEM engineers agree these operational requirements. When engineers are designing SBDS drive systems, engine temperature is one of the key factors for material types that can withstand these temperature fluctuations. Over the years, underbonnet temperatures have been increasing, mainly due to smaller engines with higher outputs within smaller engine compartments. If we manufacture a belt with just rubber tooth compound, tooth facing fabric, back compound and fabric, the belt would be like a big elastic band and would elongate or stretch. Elongation or stretch is not good for an SBDS belt. Therefore, high strength glass tensile cord packs are used to give lateral strength and stability to the belt. The rubber tooth compound is fibre reinforced for high load carry capability. Due to issues with belting oil belts, such as swell rate and deterioration, Gates' mission was to design and manufacture a belt that would not deteriorate as quick or swell as much, and therefore lasting longer. By changing certain material types and the rubber compounds, we see the benefits of the Gates belting oil. Tooth fabric is 100% aramid fabric, which is preformed and shaped with specific rubber coatings, which benefits are the better wear and chemical resistance. The tooth compound is high modulus fibre loaded and preformed with the tooth fabric. The benefits of this are maximised tooth load carry and increased lifetime and safety of the belt. The glass cord is 33% higher lay density, and the benefits of this are lower belt elongation and increased lifetime safety of the belt. The back compound is a medium modulus compound with no fibre, and the benefits are increased flex performance and better belt crack resistance. The belt back is nylon fabric and a specific rubber coating, and the benefits of this are better resistance to wear and chemicals. Tensile members. High strength glass cords with oil resistant impregnated material. Equal S and Z cords are used across the width of the belt. The S and Z cords are wound in clockwise and anti-clockwise directions to give balance to the belt. And the belt will find its natural lay or run centrally on the drive system sprockets or pulleys, and the S and Z cords align and balance the belt. If all S or all Z cords were used, then the belt would either track towards the engine or away from the engine. But by using equal amounts of S and Z cords, then it gives balance to the belt so it runs centrally within the drive system. Gates new belting oil construction. There are a couple of main visual differences. We can see this is a black tooth belt compared to the OE, which is a white tooth belt. And there is also a yellow and white stripe. Now the yellow and white stripe marking that's visible on all Gates manufactured belting oil belts is required for Gates manufacturing process purposes only. We need to be aware this is not a timing mark. It is purely for manufacturing process purposes. Gates new belting oil performance. The materials used to design the new Gates belting oil belts have been vigorously tested against the OE belting oil belts. Tests include running the belt in different types of contaminated oils. For the improved dynamic lifetime test, the new Gates belting oil belt lasted a minimum of 30% longer compared to the current OE belt. For the improved belt width swelling performance test, the new Gates belting oil belt has minimum 3 times less swell rate compared to the current OE belt. Tensioners in oil. Tensioners operating in an oil environment are manufactured differently to tensioners for dry synchronous belt drive systems. Dry tensioner versus tensioner in oil anatomy. The dry tensioner anatomy, the main damping is created by the friction between the sleeve and the bushing for a dry system. The tensioner in oil anatomy, an actual wave spring and the main torsion spring creates actual force to generate friction between the damping shims. For both dry and wet tensioners, the belt tension is created by the torsional spring. Tensioner in oil anatomy. Top damping shim. The top damping shim is connected to the arm, and no relative rotational movement between the top damping shim and the arm is possible. The actual wave spring and main torsion spring creates force to generate friction between the top damping shim and adjusting retainer. The bottom damping shim is connected to the arm. Again, no relative rotational movement between the bottom damping shim and the arm is possible, and the actual wave spring creates actual force to generate friction between the damping shim and the base. Extra information for Ford EcoBoost engines. Ford EcoBoost direct fuel injection petrol engines were first produced in 2009, designed to deliver greater horsepower and torque while also providing greater power, fuel efficiency and reduced CO2 emissions. The Ford EcoBoost range has won several awards, including International Engine of the Year. Ford EcoBoost applications installation instructions. Ford EcoBoost timing belt cover and fixing bolt sequence. Clean the timing cover and engine surfaces thoroughly before applying specific silicon sealant. Silicon sealant Ford Motorcraft WSE M4G323 is required, and the cover must be fitted within 10 minutes of applying the sealant. The timing cover fixing bolts are then tightened following the correct sequence 1 to 20 as shown in the schematic, and obviously using a calibrated torque wrench set to the correct torque values as stated in the installation instructions for the vehicle application. Please note the diagram shows for Ford EcoBoost 1 litre petrol or gasoline applications. For Ford EcoBlue 2 litre diesel applications, where the timing cover is removed, Ford recommends that it is disposed and the installation requires a new timing cover. The Ford EcoBlue 2 litre diesel timing cover has its own tightening sequence and also requires Ford specific silicon sealant. Ford EcoBoost applications. Water pump location. The water pump is part of the SBDS system. It is located on the timing belt cover. The timing belt cover needs to be removed when removing and installing a new belt and its drive system components. It is recommended to replace the water pump and SBDS system components during the belting oil system installation. Water pump sequence. If only the water pump and gasket are being replaced without removing the timing belt cover, the correct tightening sequence for the fixing bolts should be followed as 1 to 7 as shown in the schematic, using the correct torque values as also stated in the installation instructions for the vehicle application. Cover and water pump sequence. When both the water pump and the timing belt cover are removed to enable easier access when replacing the SBDS system, the water pump tightening sequence is now incorporated into the timing belt cover sequence. Therefore, the fixing bolts tightening sequence is different. We need to be aware it is important to follow the installation instructions for the vehicle application using the correct tightening sequences and torque settings, as damage to the belt cover can occur if the correct tightening sequences and torque settings are not followed. It is recommended to use the correct silicone sealant for the timing belt cover, as stated previous, Ford Motorcraft part number WSE M4G323. Continuous oil leakage is also a symptom if the installation instructions have not been followed. Ford EcoBoost timing belt cover installation. Take care when replacing the cover. The lines showing on the back side of this belt have been made due to contact with the edge of the timing belt cover. This belt is now damaged. Premature belt failure will occur if this belt is not replaced. Ford EcoBoost crankshaft oil seal and crankshaft fixing bolt. Ford installation instructions state: renew the crankshaft oil seal and renew the crankshaft fixing bolt. Oil seal replacement. When installing the new crankshaft oil seal, use the correct tooling. Gates Crankshaft Seal Installer Tool GAT5252 installs the seal to the correct depth. Crankshaft fixing bolt. When installing the new crankshaft bolt, apply the correct torque values. Gates 5:1 torque multiplier tool GAT6160 installs the bolt to the correct torque settings, including angular torque values, due to the high final torque loading required. Ford EcoBoost applications. Ford part number CM5G-6378-AA is required to be installed when replacing the timing drive system. This crankshaft friction washer is not installed at the factory when vehicle was produced. This part is required when the original engine has been stripped down for timing drive system replacement. If not replaced, pulley or sprocket slippage can occur, leading to engine problems. Ford EcoBoost applications. There has also been an update for the sprocket. The newer version is laser etched. If the newer laser etched version sprocket is installed, then diamond thrust washers are not required. Extra information for PSA-EB PureTech engines. PSA PureTech direct fuel injection petrol engines were first produced in 2012, designed to deliver greater horsepower and torque, while also providing greater power, fuel efficiency and reduced CO2 emissions. The PSA PureTech range has won several awards, including International Engine of the Year. Applications with EB engine codes. Water pump location. The water pump is part of the SBDS system, unlike the Ford EcoBoost engine. The water pump on the PSA belting oil models is installed directly to the engine and not the timing belt cover. However, it is recommended to replace the water pump and SBDS system components during the belting oil system installation. And here we can also see the timing cover location. Water pump differences for PSA-EB engines. We can see water pump 0192 and water pump 0265. They look very similar. However, the pulley diameters are different. WP0192 equals 71 millimeters, WP0265 equals 65.9 millimeters. Ensure the correct water pump is selected and installed. Visit Gates online catalogue, gatesnavigates.com for vehicle application and product details. PSA-EB timing belt cover. Ensure the timing cover and engine surfaces are clean, and always replace a new timing cover seal before reinstalling. Use the correct torque values as stated in the installation instructions for the vehicle application. PSA belt in oil timing cover differences. The most common cover used for PSA applications is this design. However, some Vauxhall applications have a different cover design. A new timing cover seal should also be used with this type of cover. The timing belt cover tightening sequences for these fixing bolts should be followed 1 to 10 as shown on the schematic diagram on screen. And we need to remember it is important to follow the installation instructions for the vehicle application using the correct tightening sequences and torque settings. It is recommended to replace a new seal for both of these style timing belt covers as mentioned previously, and damage to the belt cover can occur if the correct tightening sequences and torque settings are not followed. Continuous oil leakage is also a symptom if the installation instructions have not been followed. Extra information for the accessory belt drive system for PSA-EB PureTech engines. Differences in ABDS drive system layouts and components. ABDS schematic EB engines no air conditioning. These systems have a guide pulley but no tensioner assembly. ABDS schematic EB engines with air conditioning. These systems have a tensioner assembly and an air conditioning unit and a pulley, but no guide pulley. Vehicle applications without air conditioning. The ABDS drive belt is a Gates Micro V stretch fit type belt. The water pump drive belt is also a Gates Micro V stretch fit type belt. Special tooling is required for the correct installation of these belts. Gates SFT001 is required for installing the accessory belt, and Gates SFT008 is required for installing the water pump belt. So various Gates Micro V kits are available for replacing the accessory belt drive system on these vehicles. Vehicle applications with air conditioning. The ABDS drive belt is a Gates Micro V all-rounder type belt. The water pump drive belt is a Gates Micro V stretch fit type belt. Gates Special Tooling SFT008 is required for the correct installation of the Gates Micro V stretch fit type belt, as discussed previously. Various Gates Micro V kits are available for replacing the accessory belt drive system on these vehicles. Gates stretch fit installation tools for PSA-EB applications. The correct Gates tooling for installing the ABDS Micro V stretch fit drive belt is Gates SFT001. The correct tooling for installing the water pump drive belt is Gates SFT008. Gates SFT008 for correct installation of the water pump stretch fit belt. The water pump drive belt fixes to the rear pulley section of the crankshaft pulley and the water pump pulley. Traditional stretch fit tooling cannot be used to install this belt. The special cone-shaped adapter SFT008 is required, which fits over the front of the water pump pulley to ensure correct installation. A product data sheet is also available for SFT008. Special tools. Synchronous belt drive systems require special tools to ensure correct installation of the SBDS drive system. Belt in oil systems also require special tools to ensure correct installation. Gates product portfolio also includes special tools for both of these types of system. Gates belting oil tooling for Ford EcoBoost applications. GAT 5150. This toolkit contains the correct tools for locking and setting the engine for timing drive removal and replacement. GAT 5252 is used for installing the new crankshaft seal to the correct depth without causing damage to the seal or engine casing. Standard installation tools will not install the seal to the correct position in the engine casing. GAT 6160. The crankshaft pulley bolt has to be tightened in stages using a 5:1 torque multiplier. The stages consist of a series of specific torque values and angular movements to achieve the correct high final torque loading that's required. The 5:1 torque ratio of GAT 6160 matches the OE tool, enabling the installer to follow the OE installation instructions without having to convert any torque data, figures or angular inputs. Please note product data sheets for all belting oil Gates tooling are available on gatesnavigate.com. Gates belting oil tooling for PSA, Vauxhall and Toyota applications. GAT 5148A. This toolkit contains the correct tools for locking and setting the engine for timing drive removal and replacement. It also includes the special tool required to counterhold the crankshaft hub when removing or installing its retaining bolt. GAT 5257. For installing the new crankshaft seal to the correct depth without causing damage to the seal or engine casing. Standard installation tools will not install the seal to the correct position in the engine casing. GAT 5255. This locking toolkit will enable a quick check to be carried out to confirm if the belt has jumped as a direct result of deteriorated teeth, by confirming if the crankshaft and camshafts are correctly or incorrectly timed or synchronized. We need to be aware that if the timing belt requires replacement or further component removal will be necessary, then the GAT 5148A kit remains the engine setting and locking kit and must be used for belt replacement, camshaft valve and cylinder head service work. Please note product data sheets for the belting oil Gates tooling range are available on gatesnavigates.com. Gates belting oil tooling for PSA applications. GAT 5249 belt test gauge. The gauge is a simple method of checking the condition of the tooth belt on PSA, EBO and EB2 1 litre and 1.2 engines. Swollen belts will not fit the gauge and the belt will need to be replaced. We need to be aware that GAT 5249 can only be used to check Gates belt T360 HOB as well as the OE and competitor equivalent belts. At present, no tool is available for checking Ford applications. Please be aware as well, a product data sheet for the Gates GAT 5249 belt test gauge is available on gatesnavigates.com. Digital installation instructions for belting oil power grip kits. Scan the QR code located on the box label to access the appropriate installation instructions. Instructions can be viewed on screen and or printed if a hard copy is required. It's also available in 27 languages. Belt-in-oil component kits. The belt-in-oil drive system performance depends on every component working together. These components are wear and tear parts. Gates recommends to always change belt-in-oil synchronous belts and metal components at the same time. Gates belt-in-oil kits are the perfect solution for an efficient replacement of the belt-in-oil drive system. A single part number with everything you need in one box. Gates has all the required components for a complete belt-in-oil drive system replacement. Kits generally include a Gates power grip belt, a Gates power grip tensioner, a Gates power grip guide pulley depending on the bespoke application, Gates power grip kit accessories supporting hardware and fixings. Save time and money when maintaining belt-in-oil systems. Fit Gates belt-in-oil kits. Installing a new belt-in-oil drive system reduces the risk of comebacks and warranty returns. Be system smart and replace the full belt-in-oil drive system, not just a single part. Gates belt-in-oil super kits for PSA-EB PureTech engines. These super kits contain all the standard components discussed previously, such as the belt, tensioner, guide pulley and kit accessories. These super kits also include crankshaft fixing bolts, crankshaft oil seal, camshaft fixing bolts, a gasket for the timing belt cover, a gasket set for the cylinder head rocker covers, gaskets or seals for intake manifolds depending on the bespoke application. PSA PureTech engine range consists of naturally aspirated engines or non-turbo and turbo engines. The gasket sets for both of these engine types are different. Various super kits exist for the PureTech range, and some super kits also include the water pump drive belt, which is a Gates Micro V stretch fit type belt. Gates belt-in-oil power grip kits. Example of a standard kit, KO1 T360 HOB. Now you can see the kit contains a timing belt, a tensioner pulley and a guide pulley, and it's stated for naturally aspirated and turbo applications with either an orange or green dipstick. So the colour of the dipstick can donate components for the vehicle. Gates belt-in-oil power grip kits. Example of a super kit, KO3T 360 HOB. Now this kit contains a timing belt, a tensioner pulley, a guide pulley, a full gasket kit as we've discussed previous, the bolt kit for the crankshaft and the camshaft, and it also includes the stretch fit belt for the water pump, and this is for a naturally aspirated application. Gates belt-in-oil power grip kits. An example of a super kit, KO5 T360 HOB, and the kit contains a timing belt, a tensioner pulley, a guide pulley, a full gasket kit for a turbo application, as we can see the shape of the gaskets are different, a bolt kit for the crankshaft and the camshaft, and also a stretch fit belt for the water pump, and this is for turbo applications with orange or green dipstick. On screen we have some Gates websites for future reference. Navigates.com is Gates online cataloguing system, Gates.com is Gates corporate website, GatesTechZone.com is Gates online technical information centre. Gates is driven by possibility and developing new technology to powering progress for today, tomorrow, and into the future. Please remember gates for all of your belting oil drive system requirements. Thank you for watching